Hi folks, and welcome back to Physics with Captain Rod. I'm making this video to get you started on number 11 in homework 1-1-3. All right, so you've got a person standing on a cliff and they have thrown a rock or a ball or something with some initial velocity, and that's given in the problem here. I'm just going to call it v sub o, but this will be some number here. And everybody will have different numbers, so I'm not going to bother putting a value in there right now. So the first thing you do in any projectile problem is you draw the velocity vector, and then you break it down into its horizontal and vertical components, or what we would normally call v sub ox and v sub oy. Now, the initial velocity vector here, you'll notice the angle between that vector and the x-axis is 0 degrees. So without me, I guess, actually working it out and just giving you the answers, that's what you're going to use to get these values here and here. And if you're having trouble with that, just go back through. I got lots of videos on how to do that as far as working projectile problems. The next thing you do is you draw your velocity graphs, one for the x direction, one for the y direction. And for the x direction, right, in our standard assumption is our velocity is going to be constant. So out to any time t. So this point right here is the point t, v sub ox, whatever you decide that is. Then you draw your position graph. And when your velocity is constant, your position will be linear. And then you use this area here to write an equation for x. You're going to start with delta x equals, and again, this is a rectangle. So the height times the width is going to give you your delta x. You should end up with a linear function. Okay. Your velocity graph, y direction. Now, when you have a positive initial velocity, you'd end up here somewhere. If you had a downward initial velocity, this graph would start here somewhere. This one, if you take a look at it, the initial velocity, y direction, isn't positive or negative. It's 0. And then our velocity is decreasing. This has become because our acceleration is minus 9.8 meter per second. Minus because this thing's accelerating this way. You're going to need the equation for that line. And this is your problem, so I'm not going to do all of it for you. And then this point here, right, from here to here is t. From here to here is v that you're going to have a function for. And then this area gives you your change in y. Keep in mind that's a triangle. And you're going to use that now for your position function, which should look something like this. So that's just about done. That should be enough to get that thing rolling. I hope that this video helps. Have a great day.